Hi guys, today we're going to be looking at a question on electric circuits. In the circuit diagram below, resistor R with a resistance of 5.6 ohms is connected together with a switch, an ammeter and a high resistance voltmeter to a battery with an unknown internal resistance R. The resistance of the connecting wires and ammeter may be ignored. The graph below shows the potential difference across the terminals of the battery as a function of time. At time t1, switch S is closed. Question 8.1. Define the term EMF of a battery. EMF is the maximum energy provided by the battery per unit or coulomb charge passing through it. Question 8.2. Write down the value of the EMF of the battery. As we can see, at time 0, this is the potential difference, and the y-intercept is 13. Therefore, the EMF of the battery is 13 volts. Question 8.3. When switch S is closed, calculate the 8.3.1 current through resistor R. To calculate the current through the resistor, we can say that current is equal to V over R. We know that the external voltage, which at time t is when the switch is closed, so that's when the whole circuit is in operation, is 10.5. So that is the external voltage. The resistance is 5,6, and if we plug that into the calculator, we get 1,88 ampere. Question 8.3.2. Calculate the power dissipated in resistor R. To calculate the power dissipated, we can say that power is equal to the voltage times the current, as the current is the same throughout the whole circuit. We then know that the external voltage is 10,5, and the current, which we just calculated, is 1,88. When we plug all of that into the calculator, we get 19,74 watts. Question 8.3.3. Calculate the internal resistance R of the battery. To calculate the internal resistance, we can use the formula EMF is equal to the total current times the external resistance plus the internal resistance. We then know that EMF is 13, the current is 1.88, our external resistance, as we only have one resistor, is 5.6, and R, small r, is what we want to calculate. And if we rearrange and plug all of that into the calculator, we get 1,31, that's a terrible 31 ohms. Question 8.4. Two identical resistors, each with resistance X, are now connected in the same circuit with switch S closed as shown below. The ammeter reading now increases to 4 ampere. Question 8.4.1. How would the voltmeter reading change? Choose from increase, decrease, or remain the same. Give a reason for your answer by referring to V internal resistance. The voltmeter reading would therefore decrease, as the internal volts would increase due to the increase in current of the circuit. Question 8.4.2. Calculate resistance X. To calculate resistance X, we first must get the total external resistance. So we can use the equation EMF is equal to I, external resistance being capital R and internal resistance being small r. We then know the EMF is still 13, however, the current changes to 4. The internal resistance remains the same. If we then rearrange and plug that into the calculator, we should get our external resistance to equal 1,94 ohms. We then know that in parallel, 1 over R parallel is equal to 1 over R1, which we can call this one R1, plus 1 over R2. So we can call this whole branch R2. We then know that 1 over 1.94 is equal to 1 over 5,6, as this is the resistance, plus 1 over R2. And if we rearrange and calculate that, we should get R2 to be equal to 2,97 ohms. And since we have two identical resistors, we can say that X is equal to a half times the value calculated, and we should get 1,49 ohms. And that's all for this video. Thank you.